In this video, I would like to show you some educational software that you can use with small kids and teenagers. Okay, let's have a look. One of the cool software that is available in FreeBSD is called gcompris. Here I show you gcompris configured for the German language. gcompris has very simple tasks for small kids, for example on numbers. Let's select here one task for numbers. We can, for example, use the comparison for numbers. We can save and start. And here the task is just simply to say whether the numbers are smaller, equal or larger. The first task, equal, smaller. Let's imagine that I do a mistake here. 5 with 9, 7 with 1, and evaluate the results. We got one wrong. So now we got the happy flower, we can continue. Second task, 9 with 3, 6 with 7, 1 with 8, 3 with 3, 4 with 5. Okay, it looks like I'm getting good at this. We can have some simple memory games, for example. Now I can play. I'm very lucky now. Let's have a look at other software. If your kids are learning to work with fractions, K-Bruch is a really nice software to help them out. Bruch in German means fraction, and K stands for the KDE educational project. Let's have a look at one exercise. In this case, we want to sum two fractions, 3/8 and 5. And the result should be 5 and 3/8. And finally, let's play one more. 1 minus 2/3 should be 1/3. Hooray! Looks like I'm doing great. You can do arithmetic computations, you can compare fractions, you can do some conversion, some mixed numbers, factorization, or some percentage calculations. This software is great for kids up to the 9th grade. Other real nice software is called KIG. Again, this is from the KDE educational series of software. Here we can do lots of experiments with geometry. So let's do a small experiment. Here I select a line to go through the origin, and let's put from 8 to 8. So this should be a straight line at 45 degrees. And now we can start showing some properties of algebra, for example, proportions. Let's have a look at this. For example, if we walk 2 steps forward, we will be walking 2 steps up, which is in the proportion that if we walk 7 steps forward, we should also walk 7 steps upwards. So this segment is to this segment, as this segment is to this segment. Nice. Let's have a look with another kind of line. In this case it would be 3 by 2. So this means if we walk 3 to the right, we walk 2 up, This means if we walk double, 6, we should be walking 4 up. Let's check. There we go. 4. This little program is really nice to start learning and teaching about geometry, proportions, and theorems. Another really nice software, in my opinion, is KTurtle. KTurtle allows kids to learn programming, really basic programming. Here you can see the manual page from KTurtle and the commands that you should learn in order to make the turtle move forward, backward, to turn left, etc. Let's take one example from here, copy, and paste it here. Paste. Let's run the example. The turtle moved off the screen. We press F7 to stop the simulation. And in the beginning we can just say reset. This will reset the game and reset the turtle. Instead of doing a random 20, let's just do a random of 5, walking forward. 10. Let's again do something similar, but a random between 0 and 90 degrees. And then let's turn to the left by this amount. Let's see how this goes now. We can see that the turtle looks like walking relatively random. This is also called a random walk. Press F7 to stop. So let's try to change this a little bit. Again, let's say we move forward by a small amount, let's call it 3, and we turn left also a small amount, let's call it 5 degrees. What would this be? Can you guess? Let's check it out. It's a circle. What a great way to learn programming and do geometry at the same time. Another great software that kids can use is called K-Algebra. Here some simple computations can be run. For example, 13 plus 12. The result we see already, but we press enter, 25. We can also look at things like how to sum the numbers from 1, 2, 3, from 1 to 10. The result is 55. Or we could say sum of t, where t is 0 to 10. It's 55. This is the summation of t, from t going from 0 to 10, which is the same as 1 to 10, because adding 0 doesn't count. Let's have a look at other tasks that kids can use. For example, finding out the greatest common divisor between 27 and 15. 27 is 3 times 9, and 15 is 3 times 5. So the greatest common division should be 3. Let's test it out. Greatest common division between 27 and 15. And the answer is 3, as expected. What is the least common multiplier between 27 and 15? It's 135. Let's test this out. 135 divided by 27 is 5, and 135 divided by 15 is 9. Looks good so far. Let's do some trigonometry. Sinus of 3 pi by 4 is 0.707. Okay, this looks related to the square root of 2. Let's test it out. 1 divided by the root 2, the second number means the squared root, not the cubic root, and this is exactly the same number. Okay, as you can see, this is a great software for kids in high school to learn math. Another one of my favorites is Marble. Here you can explore the planet Earth in a really nice graphical and visual way. Let's have a look in Asia, in India a little bit. Hyderabad, Mumbai, Chennai. We can have here Ho Chi Minh in Vietnam, Hong Kong, Guangzhou. We can also have a look at OpenStreetMap. Let's go back to Europe. This can give kids a notion about how far things are apart. Let's go to Rome and click on the OpenStreetMap. Here we can explore, for example, this small lake and see what is around here. I just picked some random place to have a look at. For example, between Europe, between France and the US, there goes a little bit of a long distance across the pond, right? Great software for kids to explore the planet Earth. One of my favorites is K-Tesh Lab. Here, kids can learn about electronics. Let's have a look. Here we have some sources, some passive components, discrete components, some switches, and etc. So let's try a small experiment. First, we need to create a new file. We're going to select a circuit. And in our experiment, we're just going to try to turn on an LED light. For that, we need a battery. We need a resistor. And we need an LED. Also, we need to connect everything to ground. Let's connect the components. Let's go to the tools, click on the pause simulation, and now the simulation should be running. As you can see, the circuit is working. However, I do not see the LED turned on. Why is this? If we go to this line here, we can see that there is only 400 microampere flowing through the diode. That's very less. We need at least 10 milliamps. Assuming very roughly that we have 3 volts in this resistor, to get 10 milliamps we need about 300K. A standardized resistor would be 330. Let's lower this resistor to 330. Lo and behold, the LED has turned red. How much current do we have? 12.8 milliamps, which is in the range that we would be expecting. Awesome! Another great software is WX Maxima. With this software, kids can learn about mathematics. Let's have a look. Can we also sum two numbers? 13 plus 12. Shift Enter. Yes, we can. The result is 25 as expected. But this software can do much more. Let's try to compute the sum, same as before, on t, with t running from 1 to 10. Again, we get the number 55. This is looking great. Syntax is a little bit different. Now for kids starting to learn algebra, let's try to solve a small algebra equation. So let's try to solve a times x plus b equals 0, and I want to find the variable x. The solution is x equals minus b divided by a. This is, as you can see, much more powerful than a simple calculator. It can do much more. Let's try to solve the binomial equation. Solve a times x squared plus b times x plus c equals 0 in x. Do you remember what the solution is? Don't worry if you don't remember. X Maxima can tell you. There we go. In high school, typically kids start learning about calculus. So let's try to compute a differential. Differential of x to the power n on x. What could this be? N times x to the power n minus 1. Awesome. Let's try to do something a little bit more complicated. Differential of x times the sinus of x squared in x. The result is sinus x squared plus 2x squared cos x squared. Isn't this great, the software? Let's also try to integrate. Integrate x to the power n on x. Is equal minus 1? No. Shift enter. Then it's x to the power n plus 1 divided by n plus 1. Now let's do a little bit more of a complicated computation. Let's try to demonstrate that the perimeter of a circle is 2 times pi times the radius. For that, if you remember, to compute the length of an arc, we need to integrate a function, the square root of 1 plus the differential of f of x in x, and this needs to be squared. In x. Let's first see if the equation is correct. Yes, this is how you can compute the length of an arc. Is the integral from a certain limit to a certain limit of the square root of 1 plus f prime, or the derivative of x, of f in x squared dx. How does a circle look like? The equation, we can go from the Pythagorean theorem, and we can define therefore the f of x being equal to the square root of the radius squared minus the x squared. So I think we need a semicolon. And now let's go back to this integration, and we are going to integrate between minus r and r. And since this computes only half the circle, the length of the arc, we need to multiply this by 2. Let's see if we get the perimeter. R is positive, and therefore this results in the computation 2 times pi times r. Isn't that amazing? If you still have old MS-DOS games lying around, you can also use DOSBox to run them. Here I'm going to give you an example of one of my favorite educational games for MS-DOS, called The Incredible Machine. For that, I'm going to mount the disk C, which comes from /home/tg/MS-DOS. Go to the disk, The Incredible Machine, the incredible machine. Here I'm going to show you the tutorial for the first level, where the goal is to put the ball in the hoop. This game, in my opinion, is great for creativity. When we press this image, we can start the simulation. We see one ball falls down, nothing happens, but we need to put this ball in the loop. How can we do it? We put the mouse here, and we can put the elastic band. When we do that and simulate, we can see that the second ball is starting to move. Okay, this gives us a plan forward. Let's put another one here. Let's try to simulate. Okay, looks good. Does the rubber band extend? Yes, it does. And we can put here. And we have one left. Okay, this is looking great. We just completed the game. As you can see, if you have old games lying around from MS-DOS time, you can use DOSBox to run them, and your kids are not only going to learn something about computers, they will also be able to enjoy some of your old-time favorites. That's it for today. If you have any questions or comments, please use the space down below. In any case, have a nice day. Bye bye.